In today's video, we're going to learn how to solve one-step inequalities. This is still part of Unit 5, so our color for Unit 5 is yellow. Solving inequalities is almost exactly like solving equations, with one major difference. If you multiply or divide by a negative number, you must flip the inequality symbol. So we have a couple of examples. All right, first example, I have k minus 18 is greater than or equal to negative 21. And we're going to solve and graph this. So first thing, k minus 18 greater than or equal to negative 21. Draw that line down the middle. I see subtraction, minus 18, so I'm going to use addition to solve, add 18 to both sides, and I have k is greater than or equal to negative 21 plus 18, which gives me negative 3. Notice I didn't multiply or divide by a negative number, I added an 18, so my inequality symbol stays in the same direction. So to graph this, I have k is greater than or equal to negative 3, so that means I need a closed dot on negative 3. I pick my favorite number as my test case. So let's say my favorite number is negative 5. I would plug in negative 5 is greater than or equal to negative 3. That's a false statement, so I find negative 5 on my number line. And I know that I need to shade away from negative 5, so I would shade my arrow going to the right. Okay, example number 2. I have 361 is less than or equal to negative 19x. Draw my line down the middle. I see multiplication on the side of the inequality with the variable, so I'm going to need to use the opposite operation, which is division. I'm going to divide by a negative 19, divide by a negative 19. Notice this is a division by a negative. So when I see division by a negative, I have to flip my inequality symbol. So instead of less than or equal to, it becomes greater than or equal to. So 361 divided by 19, negative, gives me negative 19 is greater than or equal to x. So I need a closed dot on negative 19, which is between negative 20 and negative 18. And then I pick a number for my test case, any number that I like, so let's try negative 25. I have negative 19 is greater than or equal to negative 25. So negative 25 is right here. That's a true statement. So I'm shading my arrow so that I cover up the negative 25. Example 3. I have negative 33 is greater than or equal to negative 20 minus x. Okay, so I find the side of the inequality with the variable. I have over here. I have a minus 20, so when I see a minus 20, in order to cancel that out, I need to do a plus 20. Negative 20 and positive 20 make 0. I'm going to add 20 to both sides. These two cancel. Notice I have a minus x. I need to remember to drop that negative sign. So I have minus x, negative x. Okay, negative 33 plus 20 gives me negative 13 is greater than or equal to negative x. Now that's not solved yet because we actually have to solve it for x and not for negative x. So if you remember from our equations unit, when I have a minus x or a negative x, in order to get rid of that negative sign, I have to divide both sides by a negative 1. And when I do that, I'm dividing by a negative, so I'd have to flip my inequality symbol. Negative x divided by negative 1 is a positive x. Negative 13 divided by a negative 1 is a 13. So I'm going to need a closed dot on 13. And then I can pick a number for my test case. So let's say 10. Plug in 10 for x. 13 is less than or equal to 10. That's false. Here's 10. So I know that my arrow needs to point away from 10. Example number 4. I have negative 13b is greater than or equal to 130. I see multiplication, so I'm going to use division. I'm going to divide both sides by a negative 13. So I have b. Notice I'm dividing by a negative number. So when I divide by a negative number, I flip the symbol. It becomes not greater than or equal to anymore. It becomes less than or equal to. 130 divided by 13. It's going to give me a negative 10. So a closed dot on negative 10. And then I can pick a number to replace b for my test case. So say I pick 0. 0 is less than or equal to negative 10. Is a false statement. So 0 would be somewhere over here. I want to shade away from 0. So my statement was false. Alright, example number 5. I have negative 19 is greater than p over 16. I see division, right? P divided by 16, so I'm going to use multiplication. I'm going to multiply by 16. I am multiplying by a positive number. That 16 is positive, so I'm not going to flip my symbol. It's going to stay greater than. So negative 19 times 16 is negative 304 is greater than p. So in this case, I'm going to have an open dot on negative 304. And then I can pick a number for my test case. Negative 304 is greater than, let's say, 300. Negative 300. That's a false statement. Negative 300 is right there. So my arrow is going to point to the left away from negative 300. Right. Example 6. I have 5 is less than x divided by negative 12. So I see division. I know I need to use multiplication. And I'm going to multiply by negative 12. So I divided by negative 12, I have to multiply by negative 12. Notice I'm multiplying by a negative number on both sides, so I'm flipping my inequality symbol. So 5 times negative 12 is negative 60 is greater than x. Again, I can pick my favorite number. I like to pick one that's on the number line usually if I can help it. So let's try negative 62. So negative 60 is greater than negative 62. That's a true statement. I need an open dot on negative 60. Here's negative 62. My test case was true, so I'm shading to the left to cover up the negative 62. Right. Example number 7. We have p minus negative 16 is less than 3. I see subtraction, so I'm going to use addition. I'm going to add the same number that I subtracted, so I'm going to add a negative 16. I'm going to add a negative 16. These two will cancel, so I'm left with p. Not multiplying or dividing by a negative number, so my symbol stays the same. So less than 3 plus negative 16. If I put that in my calculator, I end up with negative 13. So I should have an open dot on negative 13, which is between negative 14 and negative 12. I pick a number for my test case. Let's say negative 15. So negative 15 is less than negative 13. That's a true statement. So I find negative 15 on my number line right here. Since this is true, my arrow is going to point to the left to cover up the negative 15. Last example, I have negative 23 is less than or equal to v plus negative 6. I see addition, so I know I need to use subtraction. I'm going to subtract a negative 6 from both sides. Those two will cancel, so I'm left with a v here. I did not multiply or divide by a negative. I used subtraction, so this is going to be less than or equal to, not flipping my symbol. Negative 23 minus negative 6 is going to give me a negative 17. So I need a closed dot on negative 17, which is between negative 18 and negative 16. And I can pick a test case. So let's go with negative 10. I have negative 17 is less than or equal to negative 10. And there's negative 10 on my number line. This is a true statement. So I'm going to shade my arrow in the direction of negative 10.